Okay, there were really two parts to this question. First part gave you this graph of a function f. There's f of x or f of t. And then g of x was defined as this, a definite integral from 2 to x of f of t dt. And in this question number one, you were asked to evaluate things like g of -4, g of 0, etc. There's a whole bunch of choices there. And so I think you'll be using some of those to answer question 2. If we're going to let h of x equal g of 3x, that means we put this 3x into the g function. And so here's h right here. And we're supposed to evaluate the limit of h of x as x approaches 2 of h of x over x minus 2. Now, over here, I've evaluated h of 2. And the reason I drew these dotted lines is because that's the definite integral from 2 to 6 of f of t dt. And you can see that that's this region minus this region. They're opposites, so they combine to 0. And so we get 0 in the numerator, and we get 0 in the denominator. Indeterminate form means we can apply L'Hopital's rule. So how do we find, well, the derivative of the denominator, of course, is 1, but what's h prime? If we put 3x in for this t, and then apply the chain rule, there's h prime, f of 3x times 3. And now if we substitute 2 in for the x, we got f of 6 times 3, but f of 6 is -4, and -4 times 3 is -12. So that should be the answer to part A. Finding the equation of the tangent line to that function, this function right here, at the point where x equals 1, well, we have to find h prime of 1, so we can find the slope of the tangent line. But here's h prime. Put 3 in for, or 1 in for x, we get f of 3 times 3. What's f of 3? Oh, well, it looks like that's up in here somewhere. So we probably need the equation of this line, and then put 3 into the equation of that line. And it turns out the value is 2. So 2 times 3 is 6. That's the slope of the tangent line to the h function, whatever it looks like. And now to find h of 1, we put 1 into this h function. The value of this integral from 2 to 3 would be the area of this triangle. And you probably found that in part 1. But it turns out it's 3. So the point that's on h where the x coordinate is 1, comma 3. We found the slope is 6. So there's your equation, which you can convert to slope-intercept form if you want. And finally, h prime of 0. We put 0 into h prime. There it is again. F of 0 is 4. 4 times 3 is 12. Okay, so the key to this was writing h this way and realizing that the derivative of this is f of 3x times 3, or 3 f of 3x. Okay, there you go. I will supply a link to the Desmos graph that produced this, and it also has graphs of G and H that you can enable and take a look at the tangent line. Okay, there you go. Hope that helps. If you have any questions, post a comment.